In this chapter, you will learn how to set up control comparisons using both the standard forms of analysis that we're familiar with now, crosstabs and mean comparison analysis, how to identify spurious relationships, additive relationships, or interaction in empirical data, and also how to construct line charts of the relationship between an independent variable and a dependent variable while holding a control variable constant. Visual displays add a lot of clarity and help you a lot in interpreting relationships. A relationship between an X variable, like say a party identification, and a Y variable, for example, gun control opinions, that simple relationship between those two variables is called a zero-order relationship. A zero-order relationship is an overall relationship between an independent and dependent variable. A zero-order relationship does not control for rival causes of the dependent variable. A zero-order relationship always invites the how else question. How else, besides partisanship, for example, are Democrats and Republicans not the same? Could it be those differences, those compositional differences that are explaining the dependent variable? Here's an example of a zero-order relationship. This is the empirical relationship using the American National Election Study of 2012 between partisanship, which is arranged according to protocol here. It's an independent variable along the columns, and gun control opinions. Along this row are those who think it should be more difficult, and among this row are those who believe it should be easier or remain the same in terms of how easily obtained a gun should be. And when you're looking at this is very tempting. I mean, look how strong it is. I mean, it's just very tempting to implicate partisanship here. 64% of the Democrats, drops about 20 points, 45% of independents, and all the way down to about 25% among Republicans who think it should be made more difficult. That's on the order of about a 40 percentage point decline in the percentage thinking it should be more difficult. However, as we've seen, perhaps Democrats and Republicans have compositional differences that might explain, at least partly explain, differences in gun control opinions, and gender is one of those. A controlled relationship is a relationship between an independent and dependent variable holding constant a rival cause of the dependent variable. A controlled relationship is analyzed by setting up a control comparison table. For example, this is table 5-2 in the textbook. This shows a relationship between partisanship and gun control opinions controlling for gender. Let's look at this table for a minute. And to simplify the presentation here, I've taken out the independent category of partisanship so we can see the relationships very clearly. Notice that the control variable is at the top here, gender. And before any analysis is done, we separate the entire sample on the basis of the control variable. So all the females in the sample are over here, and all the males in the sample are over here. After doing that, we can re-examine the relationship between partisanship and gun control opinions separately. For females, by comparing this number, 71.5, with this number, 31.7, and for males, by comparing this number, 55.0, with this number, 17.7. Each of these comparisons just described, 71.5, 31.7, and 55.0, 17.7 are called controlled effects. Controlled effects in this table, there are two controlled effects of partisanship on gun control opinions. The one for women and the one for men. Two controlled effects. Also, a control comparison table like this permits us, by jumping between the female and male crosstabs, to examine and evaluate the effect of the control variable on the dependent variable while controlling for the independent variable. So for example, we can look at the effect of gender among Democrats by comparing this number, 71.5, to this number, 55.0. That's the controlled effect of gender for Democrats. And similarly, 31.7 Republican females, 17.7 for Republican males. We can look at the effect of gender on gun control opinions while controlling for partisanship. So we have quite a few effects here to evaluate and to simplify and to see what's going on with this table. Let's do that. As just explained, a controlled effect is a relationship between a causal variable, x, and a dependent variable, y, within one value of another causal variable. In this case, effect of partisanship on gun control opinions while controlling for gender. Republican females, 31.7. It's a rather large difference. And in the way we gauge strength, in the simple way we're gauging strength at this point in the book, we would simply subtract these two percentages to get a gauge of how far apart they are. It's very close to 40 percentage points, 39.8 points for women. Again, we get another controlled effect for men. 55.0, this is the percentage of Democratic men who favor stronger controls, and 17.7, this is the percentage for Republican men, 17.7. Do that subtraction, we get 37.3 points. As described earlier, control table also permits us to describe the effects of the control variable on the dependent variable at each value of the independent variable. So this becomes important when you're trying to build an explanation for a dependent variable, and you want to see how much the control variable contributes and in what way. Again, we obtain the controlled effects of gender on opinions, one for Dems, one for Reps. For Democrats, we see the gender gap here is 71.5 for Democratic females and 55.0 for Democratic males. So we get a gender gap for Democrats of 16.5 points. A somewhat smaller gender gap, but in the same ballpark, I guess, for Republicans, 31.7 for men, 31.7 for women, 17.7 for men, yields a gender gap for Republicans of 14.0 points. So we've been talking about four controlled effects, two controlled effects for partisanship and two controlled effects for gender. Notice the controlled effects are real numbers. I mean, they're not estimates. You do the math and come up with this percentage point difference. What we're after when we do control comparison analysis is something called partial effects. Let's talk about partial effects. A partial relationship or partial effect summarizes a relationship between two variables after taking into account rival variables. A partial effect is a summary. It provides a one-number summary of the controlled effects. Let's pursue that point. For the partisanship gun control opinions relationship, there were two controlled effects, as we saw. 39.8 for women and 37.3 for men. Now here's a question. This is an important interpretive question. Can these two numbers be fairly summarized by one number? Can these two numbers be fairly summarized by a one-number partial effect? I would suggest that they can. They're very close in magnitude, 39.8 and 37.3. It seems fair and reasonable to say that. Controlling for gender, the partial effect of partisanship on gun control opinions is about 38 points. Now again, let me reemphasize at the risk of redundancy, this number 38 is a fair summary. It's an estimate. It's not one of the numbers that we calculated for the difference. But it seems that we could characterize the relationship for both men and women at about 38 points. All right, let's do that again for the gender gap percentages. For the gender gun opinions relationship, there are two controlled effects. 16.5 points for Democrats, that was the size of the gender gap for Democrats, and 14.0 for Republicans, the gender gap for Republicans. Now let's ask the rhetorical. Can these two numbers be fairly summarized by one number partial effect? Would we be distorting the data or not accurately characterizing the data if we were to say that it seems reasonable and fair to say that controlling for partisanship, the partial effect of gender on gun control opinions is about 15 points? It seems like a fair summary, 16.5, 14.0. This helps us to estimate the effect of gender and to simplify and condense the relationship into a one-number summary. In the previous screencast, we looked at how to set up a controlled comparison cross-tabulation. We looked at the relationship between partisanship and gun control opinions controlling for gender. And we discussed how to identify or how to calculate controlled effects and asked whether the controlled effects could be condensed or summarized by an accurate estimate called a partial effect. Let's talk now more specifically about identifying the pattern in that data. And we'll also move on to look at a very different example of an interaction set of relationships. Question: after controlling for gender, is a partisanship gun control opinions relationship spurious? Is it additive? Or is this a set of interaction relationships? Let's review. In a spurious relationship, the XY relationship greatly weakens or disappears after controlling for compositional differences or Z variables. Well, we know that didn't happen because after we controlled for gender, we had very healthy effects of partisanship for both men and women across the values of partisanship. In an additive relationship, the tendency and strength of the XY relationship is the same or very similar at all values of Z. Now, tendency can also be described as direction. In this case, the tendency would be that for both men and women, Democrats are more likely to favor gun control than are Republicans. Is that the case for women? Yes. Is that the case for men? Yes. So the tendencies are the same in terms of the direction of the relationship. Is the strength of the relationship between party identification and gun control opinions about the same across both values of Z? Well, again, the answer here is yes, because we found that the effect of partisanship was about 38 points for women and about 38 points for men. Similarly, we found similar gender gaps of a gender gap of about 15 points for both Democrats and Republicans. So we know we're dealing here with a set of additive relationships. The very different set of relationships would be interaction. In an interaction relationship, the way you know you've got interaction is that the direction, that is to say tendency, or the strength of the XY relationship is different depending on whether you're on one value or the other value of Z. And these are very asymmetrical relationships. We have one that's really quite symmetrical, and that the partial effects can be used to summarize the relationships. So I've declared that this is an additive relationship. Let's look at why. Just to reiterate, the party effect, the partisanship effect, has the same tendency, direction for women and men. That means Democrats are more pro-control than are Republicans for both women and men. And it's a similar strength. This is the giveaway. When we can look at two partial effects in this case and fairly summarize them by one, we can look at two controlled effects, and we can fairly summarize them by one partial effect of 38 points. Also note that the gender effect within parties has the same tendency in that women are more pro-control than men, and roughly the same strength for Democrats and Republicans, about 15 points. So we have a lot of symmetry here. You know, if someone were to ask you what's the effect of party on gun control opinions controlling for gender, you would say, oh, it's about 38 points. What's the size of the gender gap for Democrats and Republicans? You could fairly say about 15 points without having to qualify or to specify your answer. Now here's a graph of that relationship between partisanship and gun control opinions controlling for gender. This is the percentage favoring stricter gun restrictions. And there are two lines inside the graphic space, one for females, one for males, and both lines travel across, if you will, the values of partisanship. So here are those Democratic females way up there, over 70% favoring stricter measures. And then as you move along the female line, it drops among Republican females. So you get estimating about a 38-point drop there. Similarly for men, about a 38-point drop across the values of partisanship. The two lines are separated by the gender gap, and we estimated that gender gap at about 15 points, a reasonable, accurate partial effect for the effect of gender on gun control opinions controlling for party. So this is a visual signature of additive relationships. They have a symmetrical a calculation when you look at the partial effects, and they have a symmetrical appearance when you graph them. Just to review, for the partisanship effect, each line drops about 38 points as we move across values of party identification from Democrat to Republican. And the gender effect, the distance between the lines is about 15 points, jumping between the lower line, the male line, and the upper line, the female line. Now let's look at something quite different again, an example of interaction. I'll just go ahead and click all the bullets up here and we'll discuss this. This is an example of interaction where you have a theory or an explanation that suggests you should find interaction in the data. So this is an example where you're looking for it, you have a hypothesis that suggests it should be there, and so it's not going to be a surprise if you find it. Here's the setup. We would expect individuals' abortion opinions, X, to affect their vote choice, Y. But we might also expect the XY relationship to be stronger for people who think the abortion issue is very important, or what we call salient. For people who think, for example, abortion is the most important issue, and you have the pro-choice position, pro-life position, among those people, the relationship between abortion opinion and vote choice ought to be very strong, we're suggesting with our explanation. For those who think the issue isn't as important, I mean, we'll still see the signature vote choice on it, but perhaps your relationship will not be as strong. Salience implies interaction. The strength of the XY relationship will depend on salience, which is the value, which is the Z variable in this case. Stronger relationship at high salience, weaker relationship at low salience. Here's the table. It's a controlled cross-tabulation, just like the previous example. In this case, issue salience here, we've divided the data, the sample, into those who give the abortion issue lower importance, lower salience, and those who give it higher importance, higher salience. So that's our control variable. We have a vote choice Democratic Republican, though that's the dependent. The independent variable is comparing those who say abortion should always be permitted with those who think it should not always be permitted. So this would be the strong pro-choice position and less strong pro-choice position here. And then we've done the same on this side for high salience types. Now for this example, let's stick to the evaluation of the effect of the independent variable X on the dependent variable Y, and we'll use a percent vote Democratic at both values of the control. So for the low salience comparison, we're comparing this number among those who found the abortion issue of less salience, but who also believe abortion should always be permitted. 63.2% voted Democratic. And then, quite naturally, as he moved to those who did not hold that position, don't think abortion should always be permitted, only 45.9% voted Democratic. So something's going on there. In fact, we're looking at about if you do the subtraction there, about a 17 percentage point decline in Democratic vote as you move across values of the independent at low salience. But notice this very dramatic difference here. When you switch salience from low to high, go over here on the right side of the crosstab. Now we're looking at people who give the abortion opinion very strong importance, perhaps the most important issue of the day. And among those who think abortion should always be permitted, 82% voted Democratic versus only about 35%, 34.9% who do not hold that position. So in this comparison of percentages, you're looking at 82.0 minus 34.9, which is on the order of 47 percentage points, 47.1 percentage points. So what did we find over here? On this side, about a 17-point effect, and on this side, about a 47-point effect. So when you get used to doing this, you know when you look at differences like this, that you're dealing with interaction here. Why? Because we cannot reasonably condense these two controlled effects of 17.3 and 47.1 into a fair summary of the effect of abortion opinion on vote choice by using a single partial effect. We must keep the controlled effects separate when we discuss these relationships. If you can't condense or fairly summarize controlled effects into one partial effect, then you are almost certainly dealing with interaction. To reiterate, do we discuss controlled effects? Absolutely. That's what the table's all about. Can we condense to partial effects? No, we cannot do that. We would be misleading. We would be mischaracterizing the data. So we've got to stick with separate controlled effects. Controlled effect of abortion opinion on vote choice at low salience, 63.2 minus 45.9 equals 17.3. That's a healthy relationship. It's certainly significant. But nothing compared to this. The controlled effect of abortion opinion on vote choice at high salience, 82.0 minus 34.9 equal 47.1 percentage point difference. Question, can these two numbers be fairly summarized by a one number partial effect? No, they cannot. This is an intuitive way of thinking about interaction. When it makes little sense to settle on a one number summary of a partial effect, when empirical reality requires that you describe each controlled effect separately, then interaction is at work. And here's a graph of the relationship we just looked at. You can see the lines cross. Now, as we discussed in an earlier screencast, the lines don't have to cross for it to be interaction. But when they do, it's a dead giveaway that you have interaction. Here's a relationship, Democratic vote at low salience, and again, that's about a 17-point gradient there. There's a difference between those who not always permit and always permit. The percentage goes up in terms of Democratic vote. But it's almost like you reach into this graphic space and switch on some sort of amplifier, and you get this high salience line. Very steep gradient there, about 47 points from here to here. So in this case, we have a clear example of interaction. Why? Because the strength of the relationship, though the relationships run in the same direction, the strength of the relationship is much different at low and high salience, that is, at different values of the control variable.